In today's world, speech synthesis technology has become quite widespread. For example, it can be used to enable assistive technology for the less than abled, can be used to aid in literacy development. Firms are also using it to reach a larger audience than ever before. However, there is still a long way to go before speech synthesis technology can include all the languages and the speakers in the world. Lack of support for low resource languages has marginalized vast majority of the languages and their speakers. The project that Summer Institute of Linguistics has challenged us with is to create a scalable and easily replicable data pipeline for their text-to-speech models using Amazon Web Services utilities. It essentially takes a text input and provides a corresponding speech output. We are hopeful that this project will help scale and support the efforts that are already underway at Summer Institute of Linguistics to support these marginalized languages and their speakers. And for the next part, over to Abhishek.
Thank you, Nitin. Next is the business to analytical problem framing. This project will help SIL International create a scalable and reproducible data pipeline in AWS that will take audio and text data as input and evaluated speech synthesis models as output. We were suggested by the SIL team to incorporate Montreal Force Aligner and Cocky TTS for this purpose. In addition to that, we made use of Python, Docker containerization, GitHub, and data science as well in the process. These features were incorporated into a scalable AWS pipeline to produce the final speech output. Our audio pipeline is set to give a TTS model within approximately 6 hours, whereas it can take up to 2 days while manually training the model. Now moving on to the data section. The TTS model is trained with data from Open Bible, known for its precise and modern translations. Our pipeline leverages audio files and text translations from Open Bible, segmented into lengthy chapters. Accurate forced alignment of audio and text is critical, allowing us to obtain timings and split long-form audio into appropriate snippets for Cocky TTS training. Now I'll hand it over to Amrit.
Thank you, Abhishek. We have decided to use Amazon Web Services for building out our model. The audio data and the corresponding text output is leveraged from Open Bible. Open Bible contains a repository of spoken Bible along with their text for various different languages. They are very comprehensive, hence serve as a good input for our text-to-speech model. Once the data is dropped into an S3 bucket, the model triggers an event, which is captured by the event bridge. The event bridge then goes on to trigger various step functions. In the step functions, we have Lambda scripts that are initializing EC2 instances that are captured images of our system. These EC2 instances are broken down into various different steps. We have steps for pre-processing, Montreal Forced Aligner, post-processing, and Cocky TTS. Thus, the text-to-speech model is prepared by the EC2 instances and is then stored back into the S3 bucket. The S3 bucket also captures the logging information that is created by the EC2 instances so that the users can go and decode it at a later stage. The SNS functionality is also incorporated in our pipeline, which sends out a success or failure notification to the users in case any of the step fails. We have implemented AWS well-architected framework into our pipeline so that the pipeline is robust, scalable, and cost-effective. The audio data is then created and written back into S3 bucket when the corresponding text input is provided. Now I'll hand it over to Twisha to complete the rest of the pipeline.
Thanks, Amrit. So now I'll be walking you through the various components that we've incorporated to create this pipeline. We start by taking text and audio data that belong to the same language, and we feed these to the Montreal Forced Aligner. Montreal Forced Aligner is basically a tool that aligns the text and the speech files and gives us a text grid output. This text grid output has a timestamped annotation of all the words, and this text grid is then fed to the Cocky TTS or the Cocky text-to-speech model. Once the model is generated, we can feed any text file that belongs to that particular language to get a natural sounding output. Now I'd hand over to Niyati to get to the next steps.
Thank you, Twisha. So coming to the deployment and lifecycle management, the deployment of our text-to-speech model happens in an automated fashion. So this is a classic example of an ETL pipeline where we are extracting data from the source, which is Open Bible, and then it is getting transformed through various steps in the step function, mainly lambda function and EC2, and then it is sent out to the S3 bucket, which is our output location. Since we are leveraging a lot of AWS functionalities, this will help us automate the whole process, and also it will make sure that we are analyzing all the data functionalities and capabilities that are present in AWS. So coming to the conclusion, this project has created a scalable and a reproducible AWS pipeline, which facilitates us to throw light on many rich languages which are not very popular. This will not only help people who have reading disabilities, but will also help languages which don't really have a lot of popularity in the world to gain more popularity. Finally, I would like to thank Professor Lanham, who was our mentor for this project, and also we would like to thank Summer Institute of Linguistics, which helped us participate in this amazing project and helped us leverage a lot of technical features and many other beautiful sources available online, and to help us learn a lot. Thank you.